This is a system context diagram. The system context diagram is used to identify the internal and external building blocks. This can be used in order to see the high-level view of the system and also be able to understand how the organization can function. The system diagram consists of a boundary, which is the big circle, its components inside the boundary, and the components that are outside the boundary. The components that are located inside the boundary is used to show how the users and roles access the system and how they perform tasks. The inputs and outputs are shown outside the boundary, and they provide the viewer with information such as what things can be inputted into the boundary, what interfaces are used, and also what is outputted from the boundary. This diagram is called the entity relationship matrix. The entity relationship matrix is created from logical entities from the organization. It is a logical version of the data flow diagram, and it also leads towards the entity relationship diagram. It is used in order to find a connection between a pair of entity. For example, on the diagram in this slide, it shows that the customer and tour are two entities which are associated, therefore on the table is marked with the letter X. This is an entity relationship diagram. An entity relationship diagram, also known as an ERD, is a diagram which is used in order to show the relationships between the database entities. The ERD is created by using an entity relationship matrix. The ERD contains three main components when created. The three main components are entities, attributes, and relationships. Entities are things such as tour leader, booking, customer, etc. Another component would be attribute. An example of an attribute would be first name. This is listed under the entity table of customer, therefore meaning that attribute is used for that specific entity. The last component is relationships. This is used in order to connect the entities to each other to show the relations they have. There are two types of relationships which is used in this diagram, and these are one-to-many and one-to-one. An example of a one-to-many relationship would be the tour and booking. The tour can have many bookings, hence why it is called one-to-many. An example of a one-to-one relation would be the tour leader to the schedule. The tour leader would not have many schedules, and the schedules would not have many tour leaders, and this is why it is a one-to-one relationship. This is a data flow diagram, also known as a DFD. The DFD is used in order to allow the analyst to get a viewpoint of the current system and think about what is required in the next system. DFDs are about processes, primarily the things that are done, which is also known as activities. It shows how information is created, altered, or moved around by the system. It also shows how information is received into the system and or stored. There are four components in the DFD: the processes, the data flow, the external entities, and the data stores. The external entities in this diagram would be the customer. The data flow would be the arrows which are used, for example, tour details going towards process customer inquiries. The processes would be things such as the process booking. The data stores, which is the tour information. This is a level 2 data flow diagram. The components are still the same, but this version is more detailed. It shows you much more than level 1, and it includes extra processes such as the dealership creating a tour. This gives the analyst a deeper understanding of how the organization's data moves around the system. This is an entity life history. This shows the life of an entity process. It always has a beginning, a midlife, and an end. The number which are used below the bottom steps are called indicators. These are used in order to list the different steps that can be taken through this process. The sequence is very strict. It goes from left to right. For example, it starts with creation, then goes down to customer information, then booking tour information, and then it goes to changes. The asterisk which is used is called iteration. This means that it could happen more than once through this process. The little small circle which is used is called selection. This gives you a choice between the two things that you can pick from. For example, deletion. There is customer information deleted and customer data archived for after 1 year. These are the two choices that can be picked from deletion. This is an entity life history for the customer. As I explained in a previous entity life history, it all has to follow a specific sequence, and it all has different things such as the iteration, the indicators, and also the choices that you can make. With this one, I'll explain step by step how this customer makes an inquiry. The customer makes an inquiry. It could either be between booking a tour or providing feedback. The changes that are made could be for booking tour. They would book the tour, and then a booking confirmation would be given, and also the payment would be taken. Another change would be the amendments to the booking. There would be a confirmation of amendments for after the booking, and that would be an iteration because it can be done more than once. The deletion would be of the booking cancellation or the booking plus a year in the archive. This is part of the use cases. Use cases describe the sequence of events of someone using a system to successfully complete a process. There are story or cases of using a system. The people using the systems are called actors. Actors do not usually have to be people. The system could also be an actor as well. There are different types of use cases: high level and expanded. High level use cases are good for initial analysis. It describes a process very briefly, usually 2 or 3 sentences. Used during initial requirements gathering and helps quickly understand the degree of complexity and functionality of a system. This is a user case diagram. It represents the system's actors, use cases, and also the system's boundaries. There are 3 different components which are used in this: the actors, the processes, and also the arrows. The actors uses arrows in order to connect to the process which is in a system box. The system box is the big square. The arrow which has the extend written on it means that a step must be completed in order for the next step to happen. For example, in order for someone to check if the tour date is available for the customer, the check availability process must be complete beforehand. The include on the arrow is used to connect to the next process and move to the next step if there is no need for a condition to be completed first. This is a user case story expanded. It is often known as the actor and a system communicating with each other. It is used in order to understand more thoroughly than the higher level use case. It has 4 different components: screens, stores, behavior, and alternate actions. The screens would be things such as the main menu. The stores would be things such as the booking information. The behavior would be things such as display. The alternate actions would be things that could happen if another step didn't happen. For example, if the payment got declined, then a message would be displayed from the system saying that the payment was declined. This is a robustness diagram for booking. On the diagram, it lists the different components which are used in order to complete the diagram. The robustness diagram is created by using the user story expanded. An actor in the diagram would be the customer. The entity would be something such as the booking tour details. A boundary would be the main menu, and the controller would be something such as select. It tells you the story of how each process is made and what each part does. This is a user case story high level again. The last high level user case was very brief, so this one I will explain in more detail about the sections in the table. The user case name is the name of the user case story. The level for this user case would be secondary. This is because the customer cannot give feedback without going through the first primary level, which would be going on tour or speaking with the customer service. This is only optional because the customer does not need to give feedback if he or she does not want to. Preconditions would be things that the customer need to know before they go through with the process. The significant post conditions would be the end result. The overview will give you a brief description on what the user case story is about. It has 4 steps listed. Step 1. The customer calls up the company and asks to provide feedback. Step 2. The operator obtains the information that the customer provided and it puts into the system. Step 3. The system will display the feedback confirmation. The final step. The dealership will manage the feedback that is given in from the system. The extension scenario is when something else could happen at a specific step. For example, if the customer gives in feedback but it's too brief, then the dealership would not accept it because they do not gain much information from it.
This is another use case diagram.
That would change
It
the
has the
final
same
step
components
in the
as the
user
other
case
use
story.
case diagram, but is different because this is a process for the customer giving in feedback.
This is another user case story feedback expanded. This is an actor and a system having a conversation with each other. It starts off with the customer calls up to provide feedback. The operator then answers the phone. The operator clicks on feedback section from main menu. The system displays the feedback page. The customer provides feedback details. The operator inputs feedback details into feedback page. The system displays information. The operator clicks proceed. The system displays feedback confirmation. The operator clicks proceed to return to the main menu. The system then displays the main menu. This is another robust diagram, but this one is for feedback. The components are also listed on top of the diagram, and the story of the robustness diagram is placed on the left hand side of the slide. It gives you a deep understanding of how the feedback process is completed. This is a domain model diagram. A domain contains attributes and behaviors. The connections between each domain differentiates. The black filled diamond means that it is composition. This means it is a part of the domain uniquely and cannot exist without the domain it is connected to. The white empty diamond means aggregation. This means it is part of it but not unique to the connecting domain. Nouns are used as attributes. For example, in the department domain, tour information, tour booking information, and customer information is all used as an attribute. Verbs are used as behavior. For example, on the customer domain, the request booking, cancel booking, and make payment is the behavior of the domain. This is a state transition diagram for booking. The state diagram describes all the states that could happen in an entity. It will show each step of the event and also the result at the end. For this one, it will start by a booking being requested. It would check date, and it could either go two ways: the confirmation of the date available or the date being unavailable. If you're going from the confirmation of date available, you would have to make the payment. With the payment, it could also go two ways: payment confirmed or payment declined. If the payment is confirmed, then the tour would be booked, and that would be the finish of the section. Or we would go back to check date availability in order to go to date unavailable. If the date is unavailable, the booking would be cancelled. Once you make payment and the payment is declined, the booking is also cancelled, and that would be the end of it. This is a state transition diagram for providing feedback. It will start by the feedback being provided by the customer. The customer would then have to give in his or her details. The details would then have to be authenticated in order to find out if they are really our customer. From here, it can go one or the other way. One way would be for the customer's details to be confirmed, and then the feedback would be added. This would end the finished state transition diagram. The other way would be for the customer to have invalid customer details when authenticating. This would cancel the feedback and end the transition diagram.